Hey, this is Scott with TubeAs, and I'm back with another video to build off of some of the techniques that we used in the first pop video, as well as some of the concepts we talked about in the TimeCode TouchDesigner series from earlier this year. We'll be incorporating all of these techniques into pops using attributes and curve pops, as well as eventually particles to generate the pulses in time with our music. And but first we'll start with our simple offset attribute to move a pulse over the fixtures that we have. We can use a couple of custom parameters to create absolute value and change the direction of our pulses of light. And then beyond that, we will map the color curves and also our alpha curves to give them custom, really pretty looks over any RGB fixture. And then as we continue on with these techniques, we will introduce particles to create these pulses with specific durations to be perfectly synced up with our music that we're playing through our favorite DJ software using Ableton Link. So stay tuned. We're going to pick it up right where we left off after the last video and build all of these nodes. All right, check it out. All right, starting back where we left off after the first video, we have our dance floor here at the top of the network, and it ends with 3 point attributes on it: the position, the color, and the UV. In the next little annotate box here, we have a copy pop that is taking a line with 16 points on it, and we are using 2 lines with 4 points merged together to create our 8 LED tubes. Here on the math mix, we are generating our UV attribute, putting the null tubes into the merge that we have. We can see the tubes in our pop viewer. We use this math here to calculate the dimensions of the X and Y value, and then we are dividing the position by its dimensions to get a normalized UV value over the spread of these tubes. So you can see that you could calculate the UV to have 0 to 1 on every single one of these tubes, but instead it uses 0 to 1 over the value of its bounds. So that gives us our UV attribute, and we are generating the color attribute after our merge to give us the same 3 attributes on all of our points. From here, let's start to talk about how we can customize these looks in a GLSL pop. So while we're here in the attribute color, let's add another attribute for our offset float. And then let's shift these nodes over just a little bit and include a standard GLSL pop. Oops, GLSL. And then when we drop that down, the first thing we want to do is include offset into the output attributes parameter that we want to change. And let's open up our file in Sublime. Now that we have our GLSL script open in Sublime, this is the standard opening GLSL that comes with any new operator. And in our case, we want to affect the offset attribute, and we don't want to use P. We want to use the UV value, specifically the X value. So if I save this and go back to touch, change my attribute to offset, and you can see that our UV value, specifically the X value of our UV, is now our offset. Now from here, the script gets much more complicated. Not complicated. It's larger. And I went to go type it line by line, and it just turned into me squinting and mistyping things from moment to moment. So I'm just going to copy this in and go through it line by line with a much more straightforward description of what's happening instead of me just putzing about. I have pasted a helper function here at the top of this script called getOffset, and it is using 4 vector 2's that are declared here on line number 50 in our script. We are looking for UAT, UDIR, UABS, and ULimit, and those are referencing these custom parameters that I have pre-made on the parent operator pops2. So in order to reference those inside of our GLSL, let's go to the vector page of our GLSL POP, and as evidenced in the script, we want 4 of those vector 2's. They are called UAT, UDIR, UABS, and ULimit. They are unsigned integer vector 2's for the first 3 options. Oops, misclicked that one. And then this limit is a float. And let's just bind these custom parameters straight to our values. Oops, I meant to have a bind there. Bind. And this will link them up lockstep between our GLSL and our custom parameters. So now when I change one on my custom parameters, they also change on the pop operator. And let's go through this line by line, where down here at the bottom, the main part of the function is describing the actual action inside of the function. If we don't call our getOffset function here, then this is not run up above. So compartmentalizing some of the work that's done inside of the main is often very useful and makes for reading the script a little bit easier. So right now, let's go through the getOffset function, because that really is the only thing that's happening here. Inside of the main, we are declaring the color as black and then calling the getOffset function to receive the offset float, and then pushing our offset variable here indicated with a lowercase to our attribute, which is then living on all of our nodes beyond where it's declared. So, okay, to the action. The first thing we do is declare the offset as 0, and we use 2 floats, offset x and offset y, so that we can separately do math on them and combine them if both of these toggles are on. For now, let's just work through having the first axis toggle on, and it says if axis toggle x is 1, then the x offset is included to mean the x UV value. Then if we toggle the absolute value parameter on, we shift the now I have saved it now, so we can see how this is updating. Now, when we toggle the absolute value on, it goes middle out, and now the line beyond that says if the direction is 1, we say x offset equals 1 minus x offset. So that shifts it in to out, and also left to right if the absolute value is not on. Now, furthermore, while axis toggle is 1, if axis toggle y equals 1, then we want to say the y offset is y UV, and then use the same logic to correspond with the direction and absolute value. And then the last step that we're going to do is divide the offset by the addition of these two limits so we can get a 0 to 1 value for all of our pixels here. So to see that in action, you can kind of, if I turned this to 0.1, for instance, it just makes a sharper value, but they still go to 1 at the highest value here and 0 at the lowest value in the corners. And then if you only have the y axis toggle on, then you need not do any of this earlier math, but these logic steps are the exact same as our x offset contributions up above. Now that we have a modular way to affect the offset, let's use the offset to make the color attribute change on all of our pixels. We really don't care about pushing out an offset 0 to 1 float to all of our pixels. We really want RGB. So on this GLSL node, let's go back to our output attributes and include color. So going to our script here, we'll leave it affecting the offset ID here, but we have already declared that color is a vector for 0 black. Now let's say if the offset is less than our time, then color equals vec 1, and nothing will happen yet because we have not declared t as a identifier in our vectors of our GLSL. So we'll continue through all of these variables to include them in our vectors. First thing we want to do, is call this t, and well, I'm going to call this u time because we will be changing that later when we start working with particles. So we'll bind our u time there, and let's also, while we're here, add u tail because we'll be using that immediately, and bind that from our parameters. Okay. So now we have, and now going back to our script, we want to call this, well, let's do this. We want to declare float as t, because we do want to call it t inside of our script, but we want to be able to determine what t actually equals, and in this case, it's u time. So now, if I go back to my color, and I now can change this to color and this to lowercase color. Now we have our absolute value and our directions on, but here we go. If x is less than 1, it goes on. Okay, great. Well, let's include a little bit more nuance here. Offset is less than t, and offset is greater than t minus tail. And up above, we can add float tail equals u tail. And now, when I add that, we are able to shift the tail and shift the time. Wonderful. Now that we have our pulse moving across the fixtures, we have a problem when it gets to the very end that it actually doesn't leave the screen. So above this if statement, we need to multiply t by t plus tail. So t times equals t plus tail, semicolon, and that will give us the ability to push it all the way across the map. Now, what we want to do is declare the float inset index, which is the 0 to 1 value between the time and the tail. So we'll call I as t minus offset divided by tail. Oops. Okay. And let's say we want, oops, not I. That didn't work. Oh, this is the wrong parenthesis here. We want t minus offset divided by tail. Perfect. So now, as it goes, rate on the t is 0 and rate on the tail is 1 all the way across. If I open up the tail, then the values get spread out further. Cool. Now what we want to do is use this inset index float value to remap our color and our curve for alpha. So we need to introduce a few more uniforms into the GLSL POP. Shifting tabs on the custom parameters here, I have also included a few colors here. You could pick any which you like. These ones are just pretty distinct when you can see them on a ramp. And we'll go back to the GLSL a couple more times. We're going to put in C1, C2, and C3. Actually, I'm going to make these lowercase. They are float 4s. And once again, we will bind these parameters. Very cool. So we've got C1, C2, C3. And we're going to go back over to the script here. And let's do one more helper function to help write what our colors are going to be. That way we can call this in one line, perhaps in multiple places in our main, and be able to reuse the script. So we'll call it get color, and we want to use the uint cd for color and our float ii inset index. And now I like to declare color 0 as vector 4 for 0. And then we have we want to make a list of colors that we can reference a index of the list with our cd unsigned integer, which actually in these custom parameters I'm calling color index. And this is a integer typically. So in our get color, we are going to make a color list of vector 4s. And it is going to have 6 places in it. It is going to include C1, C2, C3, we're going to mix between 1 and 2. We're going to mix between 1 and 3. And then we will mix between 2 and 3. So now we need to describe what these mixes mean. So mix 1, 2 will equal the GLSL function mix, which blends between these colors along a float the float inset index. Okay, you can probably see where we're going with this now. We'll be doing this 2 more times, and this is going to go 3, and this is going to go 2, so we'll go mix 1, 3, mix 2, 3. Okay, and then we're going to say that the color that we are going to return is the CD index of the color list, and we will return color. Now I've gone over to our GLSL POP, and I have added one more uniform, this time a color index, and of course bound it from our custom parameter. So when we go back into our if statement on the script, I like to open up another vec4. That way we can do a little bit of math on it in a few steps before we pump it back out to the color. So I'll call this one pulse color. And for now, we can keep the variables the same with our inset index here. So I really haven't changed anything at all. It's the exact same as I save it. And now I want to pull in the helper function that we just used and call pulse color equals get color. And then I want to do the U color index. U color index. And then I want to keep the II value that we have. And now you can see that we are using the 4th color index here, which equates to 0, 1, 2, 3, mixing between colors 1 and 2, which are, oh, that's not right at all. 0, 1, 2, 3, oh yeah, 4. It's mixing between 1 and 3, which is blue and green, as the 4th. 0, 1, 2, 3, 4. If I shift my color index back down to 3, it mixes between colors 1 and 2. So that's fantastic. It is blending from 0 to 1 on the inset index as a perfect linear gradient. But wouldn't it be cool if we could take that inset index and remap it to a curve, so we could have perhaps like a small blue part of the curve followed by like a trailing pink gradient. And with that, we're going to use a curve pop. Moving right along, let's drop down a curve pop and we'll plug it into our GLSL. The curve pop is cool because you can index across its U value to assess its curve attribute, where U goes here from 0 to, in our case, 1. You can use the alpha and beta slopes to affect how that works out. And then, so we'll make 2 curves right now. This first one will be for our color, and the next one will be for our alpha. The difference between these two that we want to do is on these pulses, I like to have a fade in and out of both sides of our alpha. Meanwhile, the color kind of looks cool if it just goes from one like hot color to a cold color. So we'll change our U values in here to give us a slope, a dramatic slope in, and a gradual slope out. So we can shift this all the way over. So if this is our curve alpha, it's going straight in and then fading out. And we'll plug this into our second index of our GLSL. And let's go back to our scripts. As we mentioned before, we no longer want to use our inset index as the way that we assess our color. So we need to pull in an inset color attribute. Well, we'll be creating a variable float here, and we are going to read the curve attribute of our first input, and then there are 1,000 points in our script here, or in our curve pop. So I'm going to put a semicolon down here, and then if I call inset color, save this. Now, when I shift this beta here, we can see that our curve is changing. And then when I change our time, we can move the whole curve together on itself. Okay, that's pretty cool. Now let's bring in one more curve here, and we'll call it the inset alpha. And we can basically use the same script. All right, I'm going to roll this up so you can see it better. Sorry about that. So now we'll use td in. Well, I'm just going to copy this. It's so easy. So easy. And we just want to use the second index. Obviously, the first 0th index are our DJ fixtures and our lighting fixtures. And the second index is our color. And the third index is our alpha, but we're using 0 as 1, so you know how it goes. Sorry about the explanation there. But now we'll multiply our inset alpha. And now we have both our curves for the alpha and our color, where I can shift the alpha specifically or otherwise. So this seems like a good place to wrap up this video. It's been a pretty good recap of the techniques we talked about in TimeCode TouchDesigner Part 1. Of course, these ones are fit for pops. Wonderful development. In the next video, we'll continue working on our pop concepts with introducing the particle pop. We use point pops to stash all of the attributes that we've just declared and be able to cycle through them with different looks and pump them into the particle pop to let it do its work, and we can create individual pulses that are a certain number of beats to link up with the tempo from your DJ software. On another note, I'll be at LDI in Vegas this December, so if you see me, looking forward to meeting up with a lot of the legends out there, and if you see me, say hi. Thanks a lot for listening, and looking forward to learning with you more on future videos to come. Thanks so much. Bye.